Okay, section 2.4 is on the sine and cosine ratios, and you'll find this material very similar to what we did with the tangent ratio, except you're talking about a different ratio of sides now. So the sine ratio by definition is the length of the side opposite the angle of reference over the length of the hypotenuse. And the cosine of an angle is the length of the side adjacent to the angle of reference over the length of the hypotenuse. There's lots of ways that people use to help remember the trig ratios, and one of the most commonly used is SOHCAHTOA. So the reasons you have SOHCAHTOA is because sine is opposite over hypotenuse, cos is C, is adjacent A over hypotenuse, and tan T is opposite O over adjacent. So SOHCAHTOA. When I was in school, they did some old hags can't afford husbands till old age, but that's not talked about as much anymore. So now they just tend to use the SOHCAHTOA. You can come up with an acronym if you want, a little rhyme to help you remember that sequence of letters there to help you remember that sine goes with opposite and hypotenuse, cosine goes with adjacent and hypotenuse, and tan goes with opposite and adjacent. So the first example here asks you to use the diagram there below to find the different trig ratios that are requested. So the first one is sine of the angle theta, and this is angle theta here. So if we're looking for the sine, if you remember, just to write your definition for a few times till you get used to it, sine is opposite over hypotenuse. So if we're looking for the opposite of this angle, it would be A, side A, over the hypotenuse would be the one across from the 90, which is C. And then the next one we're doing is the cosine of alpha, and this is another Greek letter that they often use for angle symbols. And when we're using trigonometry, the three that are most commonly used are your alpha symbol, your beta symbol, and your theta symbol. Those are the three that are most commonly used for trigonometry. So alpha is this angle right here. So if we're looking for the cos of alpha, we want, and go back to your definition, cosine is adjacent over hypotenuse. So if we look at the adjacent side, when we're talking about reference angle alpha, it would be, adjacent would be side marked A, and the hypotenuse is still C, of course. The tan is opposite side over the adjacent, the ratio of the opposite over the adjacent. So tan of theta again, we're back here again at theta. So theta would be opposite would be A over adjacent would be B. And sine of alpha, back to opposite over hypotenuse again, but this time coming from the angle marked alpha. That would be opposite would be B over hypotenuse C. Okay, so we'll try a few examples. So the first three, sine, cos, and tan, are of theta. So we're going to work with this angle here. So if this is the angle that we're using, this would always be the hypotenuse because it's the line across from the 90-degree angle. But if in reference to this angle, E would be the adjacent, and F would be opposite. So if we're looking for the sine of theta, we're looking for the opposite, which is F, over the hypotenuse, which is D. If we're looking for the cosine of theta, it's adjacent over hypotenuse, so that would be E over the hypotenuse would be D. And the tan of theta would be opposite, which is F, over adjacent, which is E. Now if we switch to angle alpha, now this is no longer the adjacent, and this is no longer the opposite. This is the opposite. E is the opposite to angle alpha, and F is the adjacent. So the sine of alpha would be the opposite, which is now E, over the hypotenuse, which is still D. And the cosine of alpha would be adjacent, which is F, over hypotenuse, which is still D. And then we have the tan, which is opposite of alpha, which is E now, over adjacent, which is F. So in example B, we have coming from angle theta, this would be the hypotenuse, the side across from the 90. This one would be the opposite of theta, and this would be the adjacent of theta. So sine of alpha would be opposite, which is Q, over the hypotenuse R. Cos would be adjacent, which is P, over the hypotenuse, which is R. And tan would be opposite, which is Q, over the adjacent, which is P. Now if we switch from angle alpha, I didn't mean to erase the hypotenuse there because hypotenuse is not going to change, but if we switch to alpha, this is still the hypotenuse, but now this is the opposite to angle alpha, and this is adjacent to angle alpha. So sine is opposite over hypotenuse, is going to be P over R. Cos is adjacent over hypotenuse, is going to be Q over R. And tan of the alpha is going to be opposite over adjacent, which is P over Q. And our next examples, we have sine of theta, opposite now would be this one, adjacent would be this one, and hypotenuse would be this one. So sine would be opposite over hypotenuse, would be 3 over, we don't have the hypotenuse, so we're going to have to figure that out. 3 squared leg squared plus leg squared equals, call the hypotenuse x squared. That's going to be 9 plus 16 is x squared. So x squared is 25. So the square root of x squared is x, equals the square root of 25, which is 5, so x is 5. So sine, go back to sine now. Sine is opposite over hypotenuse, would be 3 over 5. Cosine would be adjacent, which is 4, over the hypotenuse is 5. And tan would be opposite over adjacent, which is 3 over 4. And then sine of alpha, we have to change this now to our opposite of alpha, and this to our adjacent of alpha. I'll just erase that and put it on alpha there. So alpha now would be opposite, would be 4. Hypotenuse is still 5. Cosine of alpha is 3. Adjacent over hypotenuse is 5. And tan is opposite, which is 4. Over adjacent, which is 3. And the next one, we have theta right here, so sine, this would be the opposite, this would be the adjacent, and this one is across from 90, so that would be our hypotenuse. So we would have sine of alpha, sine of theta, sorry, is opposite, which is 12 over 13 is the hypotenuse. Cosine is adjacent, which is 5 over hypotenuse is 13, and tan is opposite, which is 12 over adjacent, which is 5. So now if we move to angle alpha, the 5, side marked 5 becomes the opposite, and the side marked 12 becomes the adjacent. And of course the hypotenuse is still across from 90, so that doesn't change. So sine of alpha would be opposite, which is 5 over hypotenuse 13. Cosine would be 12, the adjacent, over hypotenuse. So 12 over 13. And tan would be the opposite, 5 over the adjacent 12. If you look back at your examples for all 4 of these questions, you should notice that when you switch from one acute angle of the right triangle to the other acute angle, basically the sine and cosine values change. So what used to be sine of the angle of theta is actually the cosine of alpha. And the value for cosine of theta is actually the sine of alpha, because basically the only thing that's switching is the adjacent and the opposite, which are your definitions for sine and cos. Sine uses the opposite and cos uses the adjacent, and both are over the hypotenuse. Okay, now so we're going to try some examples where we would use trigonometry to find missing angles. And this section is very similar to how we did it with the tan ratio, because sine and cosine are just other trig ratios. So first we look at our triangle to decide which sides we've been given, whether it's the hypotenuse, the opposite, or the adjacent. And then we would decide which trig ratio would be most appropriate to use. So for example, if you were given the opposite and the hypotenuse, sine would be more appropriate. If you're given the adjacent and hypotenuse, cosine would be more appropriate. And the next step would be then to set up the proper trig equation, and then use if you're looking for the angle, you would end up using your inverse trig to find the missing angle. So we'll take a look at the first couple of examples here. So just keep in mind our SOH, CAH, TOA to help us decide which trig ratio we're going to use. So the first example, we have theta is the angle we're looking for, and in reference to theta, 12 is the adjacent side and 20 is the hypotenuse. So when we think about SOH-CAH-TOA, if we've got the adjacent and the hypotenuse, it would make sense to use the cosine formula. So cos of the angle is adjacent over hypotenuse. So you don't have to write out cos of theta is adjacent over hypotenuse all the time. It's just we're writing out first few times just until you get used to the definitions of cos and sine. So the cosine of theta is adjacent, which is 12 in this case, and the hypotenuse is 20. So to get the angle by itself now, you would have to use the inverse cos of 12 over 20. And when you put that in your calculator, if your calculator operates in the way that you have to put the ratio in first, 12 over 20, make sure you complete that operation before you hit inverse cos. Or as my calculator does, I put it in the way it's read, so I hit the inverse cos. A bracket automatically comes up, and if it doesn't come up, you should put one in there if you're going to use division to write the fraction. So cos inverse of 12, cos inverse bracket, 12 divided by 20, close your bracket, and that gives you 53.3. If you're getting an error message when you try to find the inverse cos, you're probably not putting the brackets in properly, and your calculator is probably trying to evaluate the inverse cos of 12, which is impossible, and you'll learn a little bit more about that in later chapters in math. But right now, if you're getting an error message, you're putting it in incorrectly. If you can't figure out what you're doing wrong, come see me. Alright, so the next, so that example of angle was 53.1. In question B, the angle that we're looking for in terms of the information that we're given in the triangle, 7.2 is opposite that angle, and the 13.6 side is adjacent to the angle. So therefore, if we were looking at SOH-CAH-TOA again, if we have the opposite and adjacent, we'd be concentrating on tan information. So tan of the angle is opposite over adjacent according to its definition. So therefore tan of the angle would be 7.2 over the adjacent is 13.6. So if you're looking for the angle, use inverse, and we've got inverse tan of 7.2 over 13.6. So inverse tan bracket 7.2 divided by 13.6 and close my bracket gives me that the angle is about 27.897 on my calculator. So that's approximately, so if you want to round that off to one decimal place, that would be 27.9 degrees. Okay, example 3. is a written description, and you have to draw your own diagram. So it says a building is 21 meters tall, casts a shadow that's 25 meters long. Determine the angle of elevation of the sun to the nearest degree. So the building is 21 meters tall, and it casts a shadow, so shadows run along the ground, of 25 meters. And it says the angle of elevation of sun to the nearest degree. So that would be at the end of the shadow looking up to the sun. And your angle of elevation means from wherever your viewpoint is, so right here, there's your horizontal line, the ground would be your horizontal, so if you measure up from that, that would be your angle of elevation. So you are looking for theta. And again, we have a right triangle, and this would be the opposite, and this would be the adjacent. So in terms of the information that we have, if we think about TOA, this is opposite and adjacent, goes with tan again. So we would have tan of the angle is 21 over 25. So therefore the angle is inverse tan of 21 over 25. And again, if you put that in your calculator, you get approximately 40 degrees. If I round it off, it's 40.03, so on, approximately. So if you round it off to the nearest degree, that would be 40 degrees. Example 4 says a telephone pole is 60 feet tall. A guy wire 75 feet long is attached from the ground to the top of the pole. Determine the angle between the wire and the pole to the nearest degree. So a telephone pole is 60 feet tall. And it says a guy wire 75 feet long is attached from the ground to the top of the pole. So top of the pole down to the ground. And again, for some reason when I'm using the stylus, I have squiggly diagonal lines, but it's the best I can do. Okay, so this is 75 meters, or feet, sorry. This guy wire. This would be a right angle because it's a vertical line and a horizontal line. And you are looking for the angle between the wire and the pole. So this is the pole, and this is the wire. So this is the angle that you're looking for. So if we look at the information that you have here, you have, in reference to that angle, 60 would be the adjacent side, and 75 would be the hypotenuse. So when you think about your SOHCAHTOA, if you have the adjacent and the hypotenuse, you would be using cosine. So cosine of the angle is adjacent over hypotenuse. Cos of the angle is 60 over 75. So the angle is inverse cos of 60 over 75, which is going to be 36.8698, so on. So that is approximately to the nearest degree 37 degrees. Okay. Example 5. A truck is driving up a hill. After driving 150 meters along the road, the truck's altitude increased to 135 meters. What is the measure of the angle of inclination of the road? So this one here, we have truck is driving up the hill after driving 150 meters along the road. The truck's altitude increased to 135 meters. So that would be an altitude of 135 meters here. And if we connect those, this would be a right triangle. And it says what's the angle of inclination of the road. So the road would be, the angle of inclination would measure with the horizontal here up. So that would be the angle we're looking for. And if you look at the information, the sides, with reference to that angle, this would be the opposite. And this side here would be the hypotenuse. So if you think of SOHCAHTOA, based on the information we have here, it would be sine that we would use. So sine of the angle is opposite over hypotenuse. So sine of the angle would equal, opposite is 135, hypotenuse is 150, and then the angle would be the inverse sine of that, which, if you check on the calculator, would be inverse sine of 135 divided by 150 would be 64.158 so on degrees. So the measure of the angle, if we round that off, that would be approximately 64 degree inclination, angle of inclination. Alright, so that's the end of that section, and there are some questions there on pages 95, 96 of your textbook that you can try to practice this material.